What challenges exist when modeling population dynamics with real data? Imagine trying to predict how a flock of birds will move or how a herd of deer will grow. It sounds simple, but when you look closer, many obstacles make this task tricky. Let's explore what makes modeling population dynamics with real data so challenging. First, populations are complex systems. They involve many factors like birth rates, death rates, migration, and environmental changes. These factors interact in ways that are hard to predict. For example, a sudden drought can drastically change the population, but models might not catch that quickly. The interactions among these elements create emergent properties that are not obvious from just looking at individual parts. Second, data limitations pose a big problem. Collecting accurate population data is tough. Sometimes, scientists only get partial information because sampling is incomplete or measurements are off. For instance, counting every animal in a large forest is impossible, so estimates are used. These estimates can have errors or gaps, making it harder to build reliable models. Also, environmental data might be more detailed than population data, creating mismatches that complicate analysis. Third, estimating parameters such as how fast a population grows or the maximum number it can reach is difficult. Natural populations rarely follow perfect patterns. For example, logistic growth models assume a stable carrying capacity, but in real life, this capacity can change over time. When parameters are off or fluctuate, models may not fit the data well or give misleading predictions. Next, choosing the right model adds another layer of difficulty. Simple models like the logistic curve are easy to use but may oversimplify reality. More detailed models can better reflect actual populations but requiring more data and computational power. These complex models are harder to interpret and may still not capture all the real-world processes. Scale matters too. Population changes can look very different over small areas or short time frames versus larger regions or longer periods. Combining data from different scales can help, but it is often limited to narrow windows. Picking the correct scale for analysis is essential but not always straightforward. Finally, collaboration between scientists who focus on theory and those who gather data is important. Often, these groups work separately, missing opportunities to improve models with real-world insights. Better communication and joint efforts can lead to more accurate and useful models. Despite these hurdles, modeling population dynamics remains vital. It helps us understand how species respond to environmental changes, manage wildlife, and conserve biodiversity. Overcoming these challenges involves careful data collection, selecting suitable models, and working across disciplines. In short, the main challenges in modeling population dynamics with real data include dealing with the complexity of populations, data quality issues, difficulties in estimating parameters, choosing appropriate models, scale problems, and the need for teamwork. These obstacles reflected the unpredictable and changing nature of living systems and reminded us that combining theory with real data is key to making meaningful predictions.